This is a lesson overview on direct variation, and direct variation can be represented by the equation y equals kx, where k does not equal 0, right? So in this equation, k is what we call the constant of variation, and it is actually the coefficient, which means it's the number in front of the x. Okay, so we've got a few examples here of some equations, and what I'm going to do is I'm going to take them and I'm going to put them into the appropriate columns. We've got a column labeled examples of direct variation. We've got a column labeled equations that are not direct variation. Take this first equation, y equals 2x plus 3, and that would not be direct variation because of the plus 3. And if that plus 3 were not there, then it would be. If we take the y equals negative 3x, that is going to be direct variation. Y equals negative 3/4 x would also be. Y equals 1/4 x would be over there. When we get to y equals 4x minus 2, again, that's not going to be direct variation because of the minus 2. Okay. Y equals x over 7 is going to be direct variation because we could actually write that as 1/7 x. Okay, so therefore the k would be 1/7. The one in green here is not going to be direct variation because of the plus 4. And then the last one on this list, y equals negative x over 3, we could write that as negative 1/3 x, so therefore the k would be negative 1/3. Okay. Now, if we're given equations that are not written or solved for y, we can still figure out whether or not they're a direct variation equation by simply solving for the y. Okay, so once we solve for the y, if they're in the form y equals kx, where k is not equal to 0, then it would represent a direct variation. Okay. If we take and look at a couple of scenarios, you're either going to have positive direct variation or negative direct variation. It's going to depend on the slope of the line. And if we look at the situation that we have here in red, as the x value increases, the corresponding y value increase. So that would look something along those lines there. Okay, same thing. This time in blue, we have as x values decrease, the corresponding y values decrease. So we're going to have, that's not very straight, but that is the line that we would have there. And what you'll notice that both of these graphs, they're both going through the order pair 0, 0. And that is actually something that always needs to happen when we have a direct variation equation, that it will pass through the origin or the order pair 0, 0. Okay, so what we're going to do next is we're going to take a look at a couple of examples. Okay, so the first example that we have up top here is a problem that is in standard form where we have, does 3x plus 7y equals 0 represent a direct variation? If so, find the constant of variation. So according to what we had previously, what we need to do is we need to solve this equation for y. Okay? What I'm going to do is I'm going to draw what we call the river, or you can call it whatever. But what we're going to do is we're going to work on opposite sides of the river. So we start out by subtracting 3x from both sides. Bring this down, that gives us 7y. The 3x's are going to cancel out, and that will be equal to negative 3x. The next step in this problem would be to divide each side by 7. Again, we're using the inverse operation, so since this is 7 times y, we're going to divide by 7. And it leaves us with the equation y equals negative 3/7 x. Right? So then at that point we should be able to say yes, this is direct variation. Okay? And the constant of variation k in this case would be negative 3/7. So that is going to be k right there. That's our constant of variation. So we would have negative 3/7. Alright, in the next problem that we have suppose y varies directly with x and y equals 8 when x equals negative 2. What direct variation equation relates x and y, and what is the value of y when x equals negative 8? So most of you who have had previous experience are probably going to want to just set up a proportion. But what we actually have to do is we actually have to come up with the equation because of this part right here. What direct variation equation? So we do have to come up with the equation. So I'm going to use the y equals 8 and the x equals negative 2. And again, the equation is y equals kx. So I'm just going to substitute those values in. 8 equals k times negative 2. So I'll divide each side by negative 2. So now negative 4 is equal to k. If I use that to write the equation is going to be y equals negative 4x. All I do is take the k and replace it there. Alright, so now I can actually take that and substitute it in right here where we have x equals negative 8, y equals negative 4x, negative 4 times negative 8. So the value of y is going to be 32. Alright, and the last problem we're going to work on is a problem about Ohm's law. Okay, and Ohm's law is an example of a direct variation. It's given by the equation V is equal to I times R. Okay, and V represents the voltage in volts, I represents the current in amperes, and R is the resistance of a circuit. Alright, so the first problem that we're going to have with this is to find the voltage of a circuit with a current of 20 amperes and a resistance of 4 ohms. So if I write the equation down, V equals I times R. And I'm just going to plug in what I know. 20 amperes, that's my current. 4 ohms, okay, that's going to be my resistance. Alright, and somewhere up there we should have said that ohms was R. Okay, so we want to find the number of volts. That's going to be 20, and that would be 4. So therefore, the number of volts would be 80. If I can spell. All right, so that would be 80 volts. All right, and part B. Again, we're using the same equation, but this time we're looking for the resistance. So this time we're given a voltage of 60 volts, so in place of V we're going to put 60. We're also given 30 amperes, so in place of I we're going to put 30, and then we're multiplying by R. So in order to solve this equation for R, we divide by 30. We end up with R is equal to 2, and in this case it would be 2 ohms. Alright, one last problem that we're going to look at with direct variation. The problem reads, if it costs $3.20 for 4 oranges, how much would it cost to purchase 7 oranges? So what I'm going to do is I'm actually going to go ahead and just skip the equation part instead of coming up with our constant of variation. I'm actually just going to set up a proportion. Okay? And there's a lot of different ways that we can set up the proportion. As long as we stay consistent, we should be just fine. Okay, so I'm going to put the money amount on top, and I'm going to put the number of oranges on the bottom. So I'm buying $3.20, and I get 4 oranges. So over here, I'm going to put money on top. So this is our dollar amount, and we don't know, so I'm going to let that be X. And we want to purchase 7 oranges, okay? And in order to do this, solve this equation, all I'm going to do is cross multiply. So I multiply that way and that way. And when I cross multiply, I end up with 4x. is equal to 7 times 320, and 7 times $3.20 gives me 22.4. Then I divide each side by 4, and that gives me x is equal to 5.6. But I need to make sure that I answer the question, and since we were asked how much would it cost to purchase, okay, we're talking about money, so I'm going to put it back as $5.60. So there's your lesson overview on direct variation.